In this video, I'm going to cover our second part of talking about the mole in chemistry. This has to do with molar mass. We have two objectives for this video. First, that molar mass, what does it mean? How much does a mole of something weigh? So if we were to weigh a mole of atoms, how would we calculate that weight? And second, we'll talk about molar mass conversions when we switch between moles of a chemical and grams of a chemical. So first, let's talk about molar mass. Again, we're going to talk about how much that 1 mole of a chemical weighs. So first, we need to talk about atoms. Different atoms have different masses. If we take an atom such as hydrogen, we'll look at an isotope that has 1 proton and 0 neutrons. This would have a relatively small mass. There's just not a lot of stuff in it. But if we look at something like copper, one atom of copper, one type of copper, would have 29 protons and 35 neutrons. Compared to hydrogen, this would have a relatively large mass. There's much more stuff in it, many more protons and neutrons. But because 1 mole is always equal to a specific amount of atoms, 6.02 times 10 to the 23, it doesn't matter if we're talking about hydrogen or copper, there's always these many atoms in a mole. Therefore, moles of different atoms have different masses. A mole of hydrogen would have a much lower mass than a mole of copper. So how do we calculate that molar mass? Well, we use the periodic table. And we'll see that the periodic table lists the mass of 1 mole of each atom in grams. For instance, if I look at lithium on the periodic table, at the very bottom you'll see a number, usually a decimal, 6.94 in terms of lithium. If I were to weigh 1 mole of lithium atoms, I would find that it would equal 6.94 grams. In other words, 1 mole of lithium atoms is the same thing as 6.02 times 10 to the 23 lithium atoms, which would weigh 6.94 grams. So 1 mole of lithium atoms weighs that number, 6.94 grams. And you'll often see this expressed as grams per mole, or grams/mole, often abbreviated as G-MOL. We'll look at this in a different format in just a few slides. Before we get into that, though, in chemistry, we're not always working with atoms by themselves. We're often working with compounds. Those are groups of atoms bonded together. For instance, if I use this example and showcase it as atoms and groups of atoms, I can see I have 2 compounds here. Copper 2 chloride on the left, and on my product side, silver chloride. We have these combinations of atoms. We're going to focus on how to calculate molar mass of compounds on the next slide. So when we have a compound, we have to follow a series of steps to calculate the molar mass. First, we want to count the number of each element in our compound. In this element on the left, copper 2 chloride, we have 1 atom of copper and 2 atoms of chlorine. Next, we would set up our math problem. We would do 1 times the mass of copper, which we only have 1 copper, so it's 1 times copper. Because we have 2 chlorines per our compound, we'll do 2 times the mass of chlorine. Step 3, we'll fill in those molar masses, and these numbers, again, we get from our periodic table. If we looked at our periodic table, we would find copper has a molar mass of 63.55 grams per mole, and chlorine has a molar mass of 35.45 grams per mole. Next, we multiply, and finally we add. And notice I have my units here as well, 134.45 grams per mole once I added up each component. Before we move past this molecule, though, remember that molar mass can be expressed as a conversion factor. So instead of writing grams per mole, really what we're saying here is that 135.45 grams of that compound is equal to 1 mole of that compound. So we could represent it, as seen on the right here, as a conversion factor. Next, quick note about polyatomic ions. If we have something like calcium nitrate seen here, because we have this parentheses around the nitrate and a 2 afterwards, that's like saying we have 1 calcium and 2 groups of that nitrate. What I would recommend as you're getting used to this process of calculating molar mass is first distribute that 2. Because we have 2 groups of NO3, we would have 2 times 1, or 2 nitrogens, and 2 times 3, or 6 oxygens. I would recommend rewriting that as a kind of expanded molecule form. It doesn't show the nitrates as being a unit, but it does show us our count of each atom very simply. Afterwards, the process is very similar. Count the elements: 1 calcium, 2 nitrogens, 6 oxygens. Set up your problem: 1 times calcium, 2 times nitrogen, plus 6 times oxygen. Plug in those molar masses from the periodic table, multiply, and then add them up. And we can see the molar mass of our first compound, CaNO32, we would have 164.10 grams for every mole of that compound. And once again, we could take that number and express it as a conversion factor. Instead of abbreviating it G-MOL, we could say explicitly 164.10 grams of that molecule is equal to 1 mole of that molecule. We could represent it as this conversion factor seen here on the right. All right, let's talk about actually using those conversion factors. When we want to convert between grams and moles of a chemical, just like when we want to convert any units, we're going to use dimensional analysis. So let's say we know how many grams of a substance we have. This would be like if we weighed something out in the lab. We can easily convert that to moles using dimensional analysis. And as my example, I'm going to start with 250 grams of calcium chloride. First, I'm going to calculate the molar mass. You'll see why this comes in handy a little bit later on. Go ahead and pause the video to go through this process if you need, but the answer is here at the bottom. We can see that 110.98 grams of calcium chloride is equal to 1 mole of calcium chloride. Let's now convert from grams to moles. We'll start with grams calcium chloride, and we'll put it over 1, just like we always do with dimensional analysis. That's because this is a measured amount. It's not a conversion. It's not 250 grams per something, just 250 grams. Next, we'll set up our conversion factor. Notice that I kind of flipped the molar mass. We know that 1 mole of CaCl2 is equal to 110.98 grams of that compound. That's its weight for every 1 mole. Notice that I set up my grams so that they cancel, and I'm left with moles of my compound, what I'm looking for. I'll multiply my numbers straight across the top and straight across the bottom, divide, and get 2.25, and that final unit is what's left over, moles of calcium chloride. We can also do this in the opposite order. For example, if we know the number of moles of a chemical, we can convert that into grams using the same sort of method. We just have to make sure our units cancel. As our example, let's pretend that we have 1.75 moles of strontium permanganate, or SrMnO4 The first step is going to be the same. We want to calculate our molar mass, and we'll see why this comes in handy in a bit. But first, I want to point out that I'm going to expand my formula here, get rid of that polyatomic ion, just to make counting easier. And I'll distribute the 2 to say 2 times 1 Mn gives me 2 Mns, or manganese. And 2 times 4 O's gives me 8 oxygen atoms. And I have that expanded form on the right. Afterwards, I'll perform my calculation of molar mass. Go ahead and pause the video if you'd like to analyze that equation on the bottom left. And now let's use that molar mass of 325.50 grams of strontium permanganate for every 1 mole of strontium permanganate. We'll start with the amount that we know. We know we have 1.75 moles of our chemical, and we'll put it over 1. We'll set up our conversion factor next. We know that 1 mole of strontium permanganate is equal to 325.50 grams. And we set that up so moles cancel, and we're left with grams in our numerator. Next, we multiply straight across the top and straight across the bottom, and we divide, and notice that we end with grams of strontium permanganate. at 569.63. And that is it for calculating molar mass and using it for conversions.